everyone, and welcome back to the Wow Such Devlog series. This is episode 5. My name is Josh, and today we're going to be talking about one of the cooler bits of technology that we've developed for Project Icarus. We call it the expression system. Before we get into the tech, let's talk a little bit about what exactly is an expression. A simple expression could look like this: 1 plus 2. It has 3 different parts to it, and each of these parts is called a token. The first token we have is the number 1, and it's a literal token. A literal is just a fancy word for a number, which means that 2 is also a literal. The last token we have in our expression is the plus sign. This token is called an operator. The system comes with 6 built-in operators. We can expand our expression to include something a little more complex, such as the value of pi. Certain words have been mapped to constant values, such as pi and e. These tokens are called identifiers. The system includes a small selection of built-in identifiers. We can also add more identifiers by including custom variables, but we'll get to that later. We can further expand the complexity of our expression by adding a function. Functions are special types of tokens that usually require arguments and always return a value. This particular function returns a random value between 2 numbers. The system includes more than 30 built-in functions. We can also extend the expression system to include custom functions, but we'll get to that later as well. Now that we understand what an expression is, we can talk about how to retrieve the result of an expression. Looking at this expression, we can intuit that the result will be somewhere between 9.14 and 11.14. But how do we actually get to that result? There are 4 steps we must complete before we can retrieve the result of our expression. These steps are lexical analysis, which converts our expression into a series of tokens; notation conversion, where we translate the expression from a human-readable format to a computer-readable format; serialization, which generates an expression object that can be serialized using Unity's default serialization system; and finally, evaluation, which is the step that calculates the result of our expression. As you can see, there are several steps we need to figure out before we can even evaluate our expression, so let's get right to it. The first step is lexical analysis, which is also known as lexing or tokenizing. Lexical analysis is the process of converting a sequence of characters, generally known as a string, into a sequence of tokens. Notice that the white space is not included in the list of tokens. This is because white space is meaningless to a computer and would just take up extra space, so we get rid of it. Lexing is a fairly simple process. We read a single character at a time and try to determine if that character is a token on its own or part of a larger sequence of characters that represents a token. We won't be getting into the nitty-gritty technical details, but when we are done, we're left with a sequence of tokens that represents our expression. Unfortunately, the way that humans like to read expressions is different from the way that computers like to read expressions. That brings us to the next step, which is notation conversion. Humans like to read and write expressions using something called infix notation. Computers like to read expressions using postfix notation, also known as reverse Polish notation. Infix notation has the symbol, or operator, in between the numbers, or operands. Postfix notation has the operator after the operands. We perform our notation conversion by using a modified version of the shunting yard algorithm, which was first described by Edgar Dijkstra in 1961. Again, I won't be getting into the deep technical details, but we decided to modify the original algorithm because it doesn't properly support unary negation, also known as the minus sign, nor does it support functions. The next part of the system is serialization. This is where we take all of the tokens that were generated by our lexical analysis and pack them into an object that can be serialized by Unity's serialization system. In code, we have an abstract token class, which has been marked to be serializable. We also have token types for literals, identifiers, and functions. As you can see, functions are more complicated than identifiers, which are more complicated than literals. We also have an expression class, which has been marked as serializable. The expression class has a list of tokens, which again has been marked to be serialized. We also have the source of our expression. When we hold a reference to an expression in Unity, it shows up just like any other text field. We're able to do this because we're using a custom property drawer, which is one of Unity's built-in functions. The difference is this little button here. We can change our expression, and you'll see that it turns red. That's because it needs to compile again. So we can click the button and have it compile. So we finally have an expression in Unity that we can use, but how do we evaluate it? The expression class has a public evaluate function. When we call this function in our code, it will return us the evaluated value. Easy. The system wouldn't be much good if we were only allowed to use the built-in functions and identifiers. We solve this problem by using assets called providers. I've already created providers for both functions and identifiers, but you can create more by right-clicking and going to the Create menu, Wow Such, Equations, Function Provider, or Identifier Provider. In the Identifier Provider, we can type in a name for our identifier and also give it a value. And this value can be anything that is represented by a system.double in C#. We can do the same thing in our function provider. Functions, however, require a bit more information. Like an identifier, they need a token or a name, but instead of taking just a number, we're allowed to give an expression, which represents our function. The last thing we need to include is arity. Arity is just a fancy word for argument count. Our expression takes 0 arguments, so it has 0 arity. That's not very fun though, so we're going to rewrite our expression, and we're going to give it the name average, and our expression is going to return the average between two values called arg0 and arg1. And we'll compile it. And here is where we can include argument aliases. The names arg0 and arg1 are not particularly descriptive. So we can add aliases for arg0 and arg1. Our 0 alias we'll call left, and our 1 alias we'll call right. Now, if we go back to our expression, we can change arg0 to left and arg1 to right, and recompile. Now, instead of our function expecting arguments called arg0 and arg1, it will take arguments called left and right. The last thing we need to do is set our arity to 2, because we now take 2 arguments. The final piece of the puzzle is hooking up our function provider and our identifier provider. This can be done by opening Project Settings, going into the Wow Such Games heading, and Expressions. I've already hooked them up, but you can add new identifiers and new function providers and add them here. Now that we have our custom average function available to use, we can use it in an expression. So here, I will ask for the average of 1 and 10 and compile it. And I've added a little function here to log the result. And you can see the result of the average of 1 and 10 is 5.5. I can change these values to whatever I want and recompile and log the result again, and I get something different. I could also change the value of the function to divide by 3 instead of 2. And when I log this result, I now get 8.3 repeating. Now I'd like to show you a practical example of where we are using an expression. You may have noticed in our functions, we already had one called calc-magnitude. And it takes 3 arguments called distance, drag, and delta time. This is the function that we use to calculate how far the player dashes. If we play the game and unlock dash for ourselves, you'll see that the player dashes about that far. If we go in here and let's say just multiply everything by 2 and recompile, you'll see we all of a sudden dash much further. I'll put that back so that our dash isn't crazy long. And it's back to normal. All right, that's everything that I wanted to go over this time. Join us next time when we will be going over our data import system. Thanks again for watching, and we'll see you soon.